Okay, good afternoon, everyone. I'm glad you're sticking to the third day afternoon sessions. That's something already. I hope you had a good conference so far. 2 more sessions to go, and I think then it's time for the not the welcome reception, the goodbye reception. In this session, the next 45 minutes, actually, I have enough content for, I think, 2 hours to talk about, but I will try to be brief and tease everything a little bit, and then we can have follow-on discussions afterwards if there's anything that's of interest. Just a little bit about me. My name is Stefan. I've been a product manager since 2013, been with the company since 2007 in many roles. But since then, I've been dealing with interoperability in general, and these days that's also language interoperability again. So that includes Java, .NET, Python, JDBC, ODBC, all of these things. And as I picked this up again, I started to do a review of what happened in that space, where are we, what are the application life cycles for the different environments, all of these things. What do we offer? What should we offer? All of these things. And that's basically the foundation of this session. So we're going to take a tour around all the different artifacts that we support. Why do we support them? How do we support them? And how do these different language environments like Java and .NET actually work, right? When do new versions come out? When do we support these new versions and so on? So that's in general the idea of this session, to give you a quick tour of what we have and set the expectations on what we support and how we support it. In general, I mean, we now have your object script, we have embedded Python, right? Sometimes I get the question like, hey, do we even need something else? Right? Now we have everything we need. And I mean, you've heard this by Scott on Wednesday, right? Nevertheless, it doesn't matter how much you have inside your box. You always need to push data into the box, and you always need to expose the data that you have and the logic that you have. So no matter what you do, right, you need connectivity to other environments, right? And that's why we have such a huge toolbox of artifacts that you can choose from. And that can be confusing sometimes because that toolbox is so huge, because it's not just like JDBC, ODBC, like one way that we offer, but we offer multiple ways for multiple environments so that you can choose the right tool for the right use case, right? And it's very important to understand which tool is the right one for which use case, right? So in general, the languages that we support, that you see most dominantly is Java as an ecosystem, .NET as an ecosystem, even though .NET became relatively complex. Some people here know this very well. JavaScript is rather simple, and Python is relatively new. One environment that often gets forgotten that we also support is C, C++, right? So if you need to do, keep your hands down. This is usually used for those cases where we really need high throughput, low latency environments, right? Something that we use quite extensively for all the other things that we offer under the covers. The question I get all the time, most often from this guy, is how do I get my drivers, right? And as of today, at least, the normal way how you get your drivers and the artifacts is through the WRC distribution page, right? When you log in, you can download all of these components on the components page. That's the most common way how you can get access to it. When you install a kit, a full kit, you also get all the drivers automatically installed with the kit, right? So you can pull them from there. Yeah, just staying high level, right? What's new is this page that you see here. That's coming with all the cloud initiatives that Scott and Don have been talking about. So for the cloud services, we offer a page where you can download the latest drivers that work with the cloud services. So that's one page where you can download all the drivers, even if you don't have access to WRC. So that's a nice addition, a nice new step. What we're still working on, is getting all the drivers into the repositories that are native to the environments, like Maven or NuGet, so that you can directly download them. So that's on the list. With all of that being said, let's get started with Java. Java these days now is on a 6-month release cycle. We currently build for 2 versions, which is Java 8 and Java 11. Both are LTS, long-term support releases. And in general, the idea is that Java releases every 6 months, and every 4 releases is an LTS, right? So the current LTS is 17, yep. And the next one is supposed to be 21, right? So if you start a greenfield project today, ideally you start on version 17. But actually, if you look at the statistics, Java 8 is still pretty heavily used. And Java 11 is like second in place. And people are still waiting a little bit on jumping to Java 17. The reason why Java 8 is still so popular is because of Java 9, right? Because everybody is scared of the modularization that it brought. So if you have older applications, older code that you build that's quite complex, you actually have to build them into modules in order to move them on to Java 11 or newer, and that can be quite complicated. We're looking into that as well in the code sample. All the new additions that are added to the Java releases are tracked as JEPs, Java Enhancement Proposals. And these are a couple of those that you can find in Java 18, which is like the current release. You can see that they're actually doing a couple of things that we've been doing for some while, so they're catching up, which is nice. JEP 400 is really interesting, right? So default, when you start up a JVM now, is that they're actually setting the char set to UTF-8. Before it was the default char set from the environment. So that's something you have to be aware of, right? So when you start off a JVM now, that means if you're expecting to use Latin 1, then you better set the JVM to use Latin 1 and start to rework your application so that you work on UTF-8 if you can. So that's something you have to be aware of. The next one, Simple Web Server, is a very simple one, just allows you to spin up a web server. And it is meant, that's what we always say with the web server that we deliver with our product, it's meant for testing, right? For development productivity. It's not meant for production use. That's basically why I'm repeating it, because it also applies to the stuff that we deliver with Iris, which is quite important, right? One thing that we are monitoring closely is JEP 419, foreign function and memory APIs, because that's basically a new way to bridge memories between different environments. So that's what we used JNI before, in order to use shared memory between clients and the server. And this is going to be the successor of it. So that's one of the things that we are watching very closely to make sure that we deliver the best performance to you. So whenever that happens, then we pick these things up. One thing I personally really like is JEP 420. So that's an example for development productivity, actually. It allows you to do pattern matching for switch. So instead of always going for, hey, is this object an instance of int or an instance of long, you can now directly write a switch statement on the type and then add the code, which is automatically typed for you already. And that makes your code much more readable, right? So that's one of the examples that I really like about this. Java support, we have a couple of artifacts to be aware of. Obviously, the JDBC driver. I will mention this once, but this is true for all the other language environments too. You will see that this is now all including semantic versioning, right? So all the drivers include semantic versionings on their own because they are supposed to have a life cycle independent from the iris kits, right? So whenever you actually log a ticket with WLC, we don't just need the $CV string, we also need the semantic version of your driver when you have an issue with the JDBC driver or with XCP or whatever. So that's always good to keep in mind, right? XCP is for XCP. For native bindings is if you want to have a more complex model, and that's mostly meant for migration from cache to iris so that you can bring your binding over. UEMA and Spark are smaller ones. I'm not going to mention them here. What's special about Hibernate is that the support for Hibernate is outside of the artifacts because that's actually source code that's delivered with the Hibernate project. So that's a file you have to load in order to make the Hibernate support work. Okay. That's about it in a quick tour. So let's jump into a very brief demo. Here we are. So this is a very simple, small project that I built. It's targeting Java 17. And it's really just basic JDBC, so nothing too fancy. You can see that I'm constructing the connection string right here. And what's important to notice, that's something that's, well, relatively new, depending on when you last looked at it. When you're targeting localhost or the IP address for localhost, we will automatically use shared memory. You don't have to manually configure shared memory to be enabled. If we detect that you're having a local connection with iris, we will automatically use shared memory. And what that means is that the memory between the client and the server is being shared, and that makes the transfer of the data much, much faster and reduces the latency, right? So that's something you should be aware of. There's a flag that you can check programmatically to figure out if the current connection is using shared memory, right? So that's a good thing to have in mind. So scrolling down a bit, you can see we're constructing a very simple select statement. You just create a statement, execute the query, we get back a result set. We're looping over the result set. And in this case, because I have lots of data in it, I'm not always printing it out, but this is how you would access the values of the individual columns, right? You can either access them by the column position or by column name, depending on which methods you use. When you're done, you close the result set, you close the statement, you close the connection, right? Fairly straightforward. What I would like to highlight is, and that's true for .NET as well, you can use the same connection for the various artifacts and pieces of functionality that we offer. So here's another method, basically starting off the same way, right? I'm establishing a JDBC connectivity, running my query, and then I'm not closing the connection, okay? And now I'm running a couple of native SDK statements, okay? Which is basically direct global access. So on the connection that I used for my JDBC connectivity, I'm creating an iris object, which is the API for native, right? And I'm going to loop over the global for the table that I just used, and looping over it and reading the data. Okay. When I'm done with that, I'm closing the iris object, and then I'm closing the connection. Okay. The same is true if you're going to use the gateway. If you're using native, right? You can always share the same connection instead of opening multiple connections for multiple tools. And that makes everything very effective. Okay. One remark in general, if you're sitting on older drivers, you can see a significant performance boost if you just upgrade your drivers. Even if you don't have a chance to update your iris instance for whatever reasons, if you get a chance to update your drivers, that by itself can give you a performance boost, right? So I acknowledge that sometimes it takes a while to update the server, but updating the clients usually is less disruptive. So if you have that on a separate schedule and do that more often, that can be a very good practice. Okay? So jumping back and taking a look at .NET. So for .NET, we support a couple of things. ADO.NET for SQL queries, native for global access, XCP if you have a simple schema basically for your data access, but it's meant for high ingestion scenarios as well, and Entity Framework if you have a complex schema that you want to model with SQL, right? Also mentioning what we used to call the gateway, right? So I just said gateway for Java 2. We actually renamed those to external language servers. So when you go to the management portal, you will not find anything pointing you to gateways anymore. You will find the language which is external language servers. And the reason for this is because the gateways actually have become much more mature, much more functionality rich. And the biggest thing that you should take note of is that the gateways now allow bidirectional communication. So instead of just calling from Iris to the other environment, you can also call back directly, right? And that allows very effective communication, especially when you say you're going to trigger a script in another environment, and then that environment needs additional data from your Iris instance to do its calculation. Use the same connection, just read the global, just run a SQL query, get your data on the same connection, and that's very effective. Okay. So .NET is a little bit more complex because of this, right? When we said .NET, I don't know, 5 years ago, we always talked about .NET Framework, right? These days, we have a split between .NET Framework and .NET Core. And .NET Framework basically is meant for everything that is Windows specific, right? Or Azure specific. Everything that needs something, let's say, Office integration. If you need to hook into the security of the OS, you will find very specific APIs in the .NET Framework for that. .NET Core, on the other hand, is Microsoft's approach for trying to have a framework which allows you to build for other environments than Windows, right? Like also Linux. And then the mix between .NET Core and .NET Framework, what's shared is called .NET Core. The shared API, right? And there's still lots of confusion around what should I target and what should I build for when I start with a new project, right? So when you have requirements for working directly with Windows APIs for Office integration, these kinds of things, or you're going to Azure, then you need to target the .NET Framework. If you have requirements that you need to be lightweight, you need to run with containers, you want to use stuff like Xamarin and all of these things, then you're going to go for .NET Core. If you're building a library to support all your other projects that you're building, ideally you target .NET Standard, because then that can be used in both projects, .NET Framework and .NET Core. Okay. To make your life a little bit easier, there's a really good page by Microsoft which tells you exactly which APIs are available in which version of .NET Standard. Okay, so if you click here, like this one is showing .NET Standard 2.1, it tells you out of these APIs, that many APIs are available in that version. And you have to target this version of .NET Core, and you have to target this version of .NET Framework in order to be compatible. So that's a really good page to visit regularly when a new release comes out. We build for .NET Framework 4.5 and 4.6. Usually that means we're trying to target the lowest dominator in order that it works for all of the projects that you're targeting. And for .NET Core, currently we are targeting 5, and support for 6 is on the way. The support policy changed a little bit, I think 2 years ago. So what's important to know is that the even-numbered releases are LTS releases. So .NET 6, .NET 8, those are the LTS releases. And the odd-numbered releases are basically just short-lived releases which bring new functionality. So those should not be targeted for production environments. Okay. In terms of the artifacts that we build, obviously they're separated out for .NET Core and for .NET Framework. So starting with .NET Core, you see all of these are NuGet packages. We have one for the gateway, which is the external language server. We have the provider, the bindings, again, when you're migrating from Cache on Ensemble to Iris, and XCP. And for the framework, I think it looks very, very similar, right? What's new here compared to the other one is the entity framework, because that's only available in the in .NET Framework, not in .NET Core, right? The one thing we're going to talk about in the demo is PACS, the polyglot extensions, which allows you in productions to write code in another language. So you've probably seen, maybe you've seen one of the projects from Guillaume yesterday, which supports PACS for Python. What we support in the product today is PACS for Java and .NET. So that's a nice mix. How this works is in a production, you have usually like 3 major components. You have business services on the left side, you have business processes in the middle for the computation, and you have business operations on the right side in order to start actions either internally or to outside systems, like, I don't know, sending a message to SAP or storing data in an Oracle database, right? What PACS allows you to do in another environment like Java or .NET to write functionality for one specific element, in this case, a business service, and then send a message to another element in the production, which then maybe is native, like in this case. So you can define a message in .NET and send this message, this object, to Iris, and a business process can pick it up and read the values of it. On the other side, you can also construct a message in Iris and then send this to a business operation, which is also written in another environment, right? So that allows you to easily add in functionality that another ecosystem offers that we don't offer in our product right away. So that's the most common use case, right? If you want to communicate to some library that we don't offer support for directly in Iris, it's very simple to build a business operation or a business service that implements this based on a jar file or a NuGet package, right? Here we are. So let's take a look at the demo. So first of all, when you're in your system management portal, you will find a page for the external language service. And this is all pre-configured. I haven't created those entries myself. They're part of the kit when you install it from scratch. So we deliver all the configurations for .NET, for Java, for JDBC, and so on. The only thing I did is I changed the default port for the .NET server. So it's easier to see that I'm using this one. All are stopped right now. So I can start them here, I can stop them. If they're started, you can see the status on those traffic lights here, okay? This is a very simple production, which actually is part of our official PACS demo that you can download from a GitHub repo. Just changed it a little bit to simplify it. It's basically taking a file on the left side, and this business service is actually written in .NET, but it shows up here. We have a native process which takes this message and then just ships it to this operation. And this operation is also a native Iris operation and then just stores it in another file. Okay, nothing too complicated. Okay, if you're taking a look at the from file service, because of the resolution, I'm going to do this in Studio. It's easier to see. You can see the class name for this is finance.inboundpacks. And the class for this really looks very simple. It's extending nslib.packs.businessservice. And the only thing it defines is that it's using an adapter, which is the generic nslib packs inbound adapter. So the only thing we're saying here is we want not just the business service to be written in .NET, but we also want to use an adapter, which is also written in .NET. Okay, so that's the only thing we're basically saying here. And then the configuration here is quite important, right? So for the host, we're defining the gateway name, which is .NET Server. This actually is a drop-down list in the UI. So you just select the external language server that relates to it. And what happens when you start up the production, then it automatically starts the external language server, so you don't have to do that manually, right? So in the earlier days, when you had Java Gateway, you had to have a specific part in your production which made sure that the Java Gateway actually started up. All of these things are gone now. We have a dependency, and we make sure that it's automatically started when your production starts up, right? Then important, the class path, right? This is the DLL that I built in .NET, so I'm including that. And I'm also including our own DLL for packs, right? So these are the two DLLs that I'm loading. The other thing that's important is the remote class name. So what's the class name in .NET that implements this interface? That's what I'm setting here. And there's a way for handing over properties to .NET or Java and say, hey, there's a property in this class which is called target component names, and I'm setting it to the value process payment request. Okay, so you can hand over values to the other environment. And for the adapter below here, you see there's nothing too fancy here, right? It's basically the same thing. For the adapter, we're using the same external language server, setting it to the same port, and so on. Okay, so let's take a look at our .NET environment. So this is our adapter, and there's a method called onTask that we implement. So every time our production is configured to make the business service do something, in our case, it's every 10 seconds, this method is being called, right? And what we're basically doing is we're just going to enumerate the files in a certain directory. And for every file that we find in this folder, we're going to check if it's a file that we want to work. And if you want to do this, we're just going to call the method process input from the business service. Okay, that's the whole task of the adapter, right? Just find all the files and hand the files to the service. And the service is going to do the heavy lifting, right? The adapter is there for getting access to the stream, and the business service is there to actually do something with the data, right? Once the processing has been done, we're going to delete the file, or potentially you can also archive it if you want to, right? In this case, I'm just deleting it, and then we're done. The business service, as you can see here, is implementing InterSystems nslib.packs.businessservice. If it's a business operation, you inherit business operation. If it's a process, you inherit business process, right? So there's an interface for all of these pieces. Here's the one property that we set on the Iris side, the target component names. We're going to use this to send our message to all the elements in that list. And here are all the methods we can implement: on teardown, on init, on process input. These are all the methods you also know from productions anyway. So it's the same interface, the same behavior. And for on process input, we're basically just taking the contents of the file, we're reading all the lines, doing some work in our message to actually construct the message from the various lines. And then we're going through the target component names, and for every element that's in that list, we're going to send the request in an asynchronous way. Okay, that's basically what's happening here. So not too fancy. What's interesting is this is our message class that we're implementing. So you can see this is nslib.pax.message. So we're constructing the message class on the .NET side. We're not using a message class that's in Iris. And these are all the properties that we want to populate, basically, right? In the constructor, we are having all the fancy logic to split the values from the line and put them into the appropriate properties, right? But this is what we later on will see in our message trace. Okay, these are the properties that we have to memorize. Okay. So let's go back and start our production. So the business service, which is running in .NET, I've put this into foreground mode. So it actually pops up as a process, and we can see all the write statements that we wrote on the .NET side. So every 10 seconds, you will see a message like, hey, I'm checking if there are new files in my folder. Everything you see here is directly coming from a .NET process, right? So if I take a message, there we go. There it is, it's gone. And we see it here, right? So we picked up that new file, we processed it, we deleted it, okay? And hopefully, here we are. Here we see our file that we just produced with my German time zone at 11 p.m. Okay. What's most interesting is to take a look at the message viewer and take a look at the trace. So you can see that we're sending a PAX message from our service to our process, and that this is the content of the message. It's basically a JSON string which includes all the properties that we populated on the .NET side, and then we can read this in Iris and use this in DTLs, or we can push this into, in our case, in the business operation and directly work with it. There's some nice logic. This is our business operation, which then reads this message. And you can see for the request, actually, I'm not doing anything with JSON, right? I'm not serializing the JSON and working with it, but I can directly say, hey, give me the transaction amount. Because under the covers, the PAX message class does all of that work for me, because our getters and setters do that heavy lifting for you. So it feels very natural on the Iris side to work with the PAX message. Okay? What it didn't show you, by the way, is here we are. The production automatically started the external language server, right? It was stopped before, now it started, and we can see the status here, right? When I stop the production, it won't stop the external language server because it doesn't know if somebody else relies on it, right? So that's something you have to keep in mind. Okay, let's stop this. Okay. JavaScript. That's a little bit simpler. There's not too much to say here. We still have support for ODBC and for native, right? These are basically the two big things that we have. hasn't changed for a long time. So I'm also not going to show a demo here. That's basically the same stuff that we had all the time. Just covering the release mode for JavaScript on Node. It's basically on release cadence, where every even numbered release becomes the LTS. It's a little bit more complicated because even numbered releases go into the current release for the first 6 months. And after the 6 months, they become the LTS. And the reason why they're doing it from the community is this gives everybody a 6-month window to update the libraries before the current release becomes the LTS. That's the reason why they're doing it. Odd-numbered releases become inactive after 6 months. So again, don't use these for production environments. Okay. There's quite a lot in version 18 that's interesting. I'm not going to cover all of these things. What I personally find interesting is the fetch API. That's basically a new way how you can fetch resources from other environments, and it's implementing the Promise API. And that makes it very effective to write your code. It's supported by all major browsers, except for IE. But yeah, I said all major browsers, right? So that's fine, right? And there's plenty of stuff that you get from all the previous versions in there. So the odd-numbered releases are actually pretty important, even though you're not targeting them usually for production. So take a look at what happens in the odd-numbered releases too. Version 17, most importantly, added support for OpenSSL 3, which is important for security. Okay, let's skip over to Python. Python is relatively new. We do support PyODBC, which is basically SQL over ODBC. And we support DBAPI, which basically is SQL for ODBC. So you might wonder, hey, why do we support two different things, right? So when Python started originally, they implemented PyODBC because that's the standard for ODBC. But then they came up with a simpler way of working with relational data, which is DBAPI. And that's a generic way that works on all platforms to work against relational data. So if you start to work with something and you see a DBAPI, always use the DBAPI. If it doesn't have support for DBAPI, you can always fall back to PyODBC. The APIs in general are very similar. They're not, I mean, it's all about SQL on relational data. But I personally feel the DB API feels a little bit more natural. Okay. Then we support native for access to globals, and we're currently working on SQL Alchemy. That's the next thing on our list. Right, Jim? That's what I wanted to hear, right? So, releases. Actually, Python is moving pretty fast. There's still a stream of 2.x out there in the wild. We don't support that at this stage. We're targeting 3.x only. And that's moving pretty fast. The current release is 3.10. We are building against 3.9 right now. If you need support for Windows 7, that's the little mark here below, you have to target Python 3.8 or lower. So that's the one thing to keep in mind. If you're targeting 3.9 or higher, then you're Windows 10 or up. So that's something you have to keep in mind. What's new in Python 3.10? The most important thing for me personally is it supports OpenSSL 1.1.1. Which includes all the fixes for the security vulnerability we all heard about earlier this year. So that's the thing you want to keep in mind. And personally, again, I like the structural pattern matching. So if you take a look at this, it's very similar to what Java has done, actually. it gives you a switch statement which allows you to type stuff automatically. To give you an example what this looks like in real code, if you're switching on, let's say, an HTTP status code, you can group it nicely and say, hey, for all of these status code, this is the logic I want to run. For all of the other status codes, this is the logic. It has the default option. And what I really like is wherever my mouse is. There it is. Okay, you see it, I don't see it. Okay, is this case here with unions, right? So you can say, hey, this is the case for 401 and 403. And that makes your code really, really condensed and simple. Okay, off to the last demo. Here we go, the last IDE of the day. Very simple DB API example. So in this case, we're just running the method test. We're creating a table. We're populating the table with like 1,000 entries in batches of 10. And then we're querying the table to see if it worked, right? So not too complex. And if we run it, there we go, bravo, right? Looking at the code, I have one shared method for the connection string. You just call dbapi.connect with all the parameters. Now you know my password. Oh no. Creating the table, I think it's very, very simple from the API, right? You connect, you get a cursor, it's cursor based. You execute your statement. And in our case, if an exception happens, we just pass, which means, right, if the table already exists, we're just going to continue, right? Otherwise, this script would only work the first time and then break all the time, right? What's important is that you always have to commit. If you're doing something that writes, you have to commit, right? It's not enough to just close the cursor or whatever, you need to commit, otherwise nothing is going to happen. So that's the one thing you have to have in mind. Populating, in this case, the code seems a little bit difficult, but actually it's not. This piece here is basically just creating some random data, so we don't really have to take a look at this one. We're just creating an insert statement, building chunks. That's something you can skip if you don't want to work in batches, but I wanted to show how you deal with chunks. In this example, it's also online, you can take a look at it. You get your cursor and you call execute many or one of the other methods that work with batches, and you hand over your chunks and then you close it, commit it, and you're done. Okay. Again, always important, do your commit, otherwise nothing will happen. And for the query, basically it's the same thing. We're connecting, getting a cursor, defining the chunk for reading in batches, executing our SQL statement. You can get your row count and all of these things. You can either call fetch all or fetch some, fetch many. There are a couple of methods that you can call here. And then we're looping over the rows, printing them, and we're closing it. And in this case, well, we don't need a commit because we only read, right? So
Commit only for Python. Don't worry about committing.
It's from DB.
It's the DB API.
Oh, okay.
Yeah, correct. But it's very well documented actually. So if you take a look at the documentation from DB API, it's very well documented. So that's easy to figure out. So that's about it. And I see the red light flashing. Yeah.
DB API realization is finished because like when I tried it was like it started. Not everything was.
Let me put it that way. Everything I tried worked. I don't know. I think we're done, right? Yeah, absolutely.
I have Django driver, which is
Mm-hmm.
the API, which can be used
Yeah.
if you want to use with Django.
Okay. So just to repeat it for the online audience or somebody who's watching later on, Dimitri has a Django driver that's using the DP API, so take a look at that if you're interested. Wonderful. So that's everything I have to share for this session. I hope this was useful. We don't have much time for a Q&A, at least here right now, because the next speaker has to get up and running. But please, I will stay here and just find me in the back of the room or just outside and shoot me your questions. The whole team of the developers is here, sitting all across the room. Just raise your hand so that everybody can find you. So there's actually quite a lot of a crew here that can answer all of your questions as well. So I hope you enjoyed the conference so far. One more session to go, and then have a safe trip home. Take care.